Welcome learners. Back into the other video where we are almost towards the end of the topic. Right, so this is one but last section to discuss in the cycle theory. So today we're looking at the issues about proving that say particular quadrilateral is cyclic, right, or else showing that points are concyclic. There's some questions whereby you'll be asked to do that. You'll be just given like quadrilaterals, but they're not in the same, they're not having vertices attaching the circumference of the circle, like the one I have drawn here. Look at this one. Quadrilateral A, B, C, D, like that. They'll be asking you to show that this quadrilateral, which may be given some angles inside, can it be cyclic? Or say, can A, B, and C attach on the circumference of the circle? So we need to show and be able to prove that the particular quadrilateral is cyclic or not. Right. So once we are able to prove that the quadrilateral is cyclic, then the points of which we always know that the points which lie on the circumference of the circle are described as concyclic. Then we would expect points like A, B, C, D to be what? Concyclic. So it's just like we are going to do two things at the same time. If we prove that the quadrilateral is cyclic, then it means the related vertices of which must be what? Concyclic. Right, so here we are going to discuss the conditions that satisfies a particular quadrilateral to be cyclic. Meaning to say, if a given quadrilateral does not satisfy any one of the conditions here, it means that particular quadrilateral is not cyclic. Right, so what are the conditions of which that we can use to show that a particular quadrilateral is cyclic, and the related points of its vertices are concyclic? Right, so the first condition here, condition thus can be used to show the quadrilateral is cyclic is this one here. They're not much different from the properties that we have just discussed. They're almost just like them. So it's just like how to show that if those properties really exist in that particular type what? A quadrilateral, then that quadrilateral is supposed to be cyclic. Like the first one here, we are talking of if a line segment subtend equal angles at any given points. So we're relating to the that property we had to say equal chords or equal axes subtend equal angles at the circumference. But in this case, we have got a figure which has got no circle. But when you connect the points of which can give you a quadrilateral, so it's just like, is that quadrilateral supposed to be cyclic? So if you check that this one is satisfied, then that quadrilateral is cyclic. Like say, for example, here what we mean there for the first part here, for this one, you may have a figure, it may be like a question, which would be like this. Look at this. Right. Has got A, B, C, D as some of the points. So what we have here is just like as you see, here we have got line A, B is more like subtending this angle at this point D, and line A, B is also subtending this angle at C. So you connect to what I've been doing there. There are some actions in the video that have been demonstrating like the way I do here above this property, say angles subtended by the same arc are equal. So follow the videos by the link down here. You'll be able to see that this is connected to somewhere else. So if you find that now these two angles, this angle and that angle, are equal, it means sometimes you can be given the values of other angles, then you need to calculate just by calculation and realize that this angle is equal to that angle. At this moment in time, we know that the two angles, yes, they're subtended by what? AB. The angles can be equal or not. It is not something that is in the circle. Yeah, but now if you find that upon calculations, you realize that this angle is equal to that one. Then, if we are going to join D to C like that, then that what we have there is just a quadrilateral. It's a four-sided polygon, which will be described as A, B, D, C, B as a quadrilateral. So now, I make that this one is equal to that one. Then definitely, this quadrilateral must be what? Cyclic. Right. And then the related points A, B, C, and D must be what? Concyclic. That's what we're discussing here. So, matter like just check this figure that you are given. And this figure shows that there's a certain line that is subtending angles at a certain given points, and those angles are equal. Things like that. Or else, not this one, not this pair of angles. You can have what? Not chord, but now line CD, subtending angle at D. The same CD is subtending angle at A. If you realize that this angle here is equal to that angle, then this must be what? A cyclic quadrilateral. That's what we're talking about. So which means that, say, the angles sometimes cannot be equal, or they can be equal. But now they're found to be equal, then that is a cyclic quadrilateral. That is condition number 1. Talking about the line segment subtend equal angles at any given point like this one. This one is also subtending, the DA is subtending angle again at C, DA is subtending angle at B, think like that. Is this angle equal to that one? Yes, then that DCBA must be cyclic, and DCBA as points must be concyclic. Right, that's it. The second condition, if you find the figure you have is not satisfied by this condition, then check another condition. What is the second condition? The second condition is related to the opposite angles. Suppose you may have a figure that is just a quadrilateral itself, like this one here. This is now condition 2. You have got a figure like this one here, right? A, B, C, D, like that. It has got angles. That is an angle. This is an angle. This is an angle again. This is also an angle, different from each other. Fine. It's a quadrilateral. But now, by the adjective word, cyclic. Can this one be cyclic? The first condition is not satisfied. We haven't seen any given line subtending angles at any given point. So you check condition B, which says that if opposite angles, interior angles, they add up to 180 degrees. So it'd be like if you work out, so maybe solve some angles within that quadrilateral, the interior angles. What is the value of this? What is the value of that? What is the value of this? What is the value of this? Try to add. If I add D and B, you try to add angle D and angle B, if anything, you get what? What is it that you find? Is it 180 degrees? The moment you get this one, then the entire quadrilateral must be what? Cyclic. But if you don't get the sum of 180 degrees, try again to add the other pair of the opposite angles. Does it give you what? 180 degrees? And definitely, I don't think that one can give you 180 degrees if the first pair fails. So in that case, if the angles is the sum of the angles is not 180 degrees for a particular quadrilateral, then rule out that that quadrilateral is not cyclic. Only if the sum of the angles, they add up to 180 degrees, that's opposite angles, add up to 180 degrees, then that quadrilateral is cyclic. And then A, B, C, D as points separately, C and D are known as concyclic, or are described as what? Concyclic. Right, so that's it. Then again, it might happen that, say, this test is not all that ticking. It depends on what angles you are given. If you're calculating, find that you are not managing, you are not able to find the values of those angles. So it means you may have a figure that is different from this one that cannot satisfy a condition 2. Then try to test that figure by condition number 3, which now is a condition that is related to exterior angle of a cyclic quadrilateral. So now it's just like a quadrilateral, a quadrilateral is outside the circle. So you have a situation like this, a quadrilateral, we're not drawing a circle here, attaching the vertices of a quadrilateral. So we have a figure like this one here. Let's have it, and we know it is a quadrilateral X, Q, N, Y, and then you have got one side extended. That gives you what? An exterior angle like that one there. So try to check, is this angle equal to that one here? And the moment you realize that this angle here is equal to that one, these are the opposite interior angle. These angles are opposite to each other. Exterior is opposite to interior angle. If it is 60 degrees, for example, and this one is also 60 degrees, then quadrilateral X, Q, Y, N must be what? Cyclic. Right. But now if this is 60, this is maybe a different angle along, maybe talk of 100 and talk of 100. They know for sure this is 100, this is 60. This cannot be cyclic quadrilateral, but we expect this one to be 60 as such, 60 degrees. Right. Then you also describe the points X, Q, Y, N as concyclic. Because if something is cyclic quadrilateral, what do you expect about the vertices? They must lie on the circumference of the circle. Right. So these are the three conditions that can be used to test if a particular quadrilateral is cyclic. So every time you are asked to prove that two quadrilateral, okay, if a quadrilateral is cyclic, please try just to check the three conditions. Do they satisfy a particular quadrilateral? Line segments obtained equal angles at any given point. It doesn't work. Check for this one. Opposite angles are supplementary. It doesn't work. Then talk of the exterior angle of a quadrilateral is equal to the opposite interior angle. Light, things like that. But all the three does not work, then it means the particular quadrilateral again is not what? Cyclic. And the points are not what? Concyclic. Right. So can we have an example in relation to the first condition? Right. For the next meetings, we'll be able to have examples again for the other two conditions. Right. So let's see. We have known the first condition and what type of problems do I expect to use that condition. Right. So here I have got an example just to give you a foresight of what will be expected from the first condition. Right, so this one here, it's not also as difficult. Just a matter of like matching or pair and match. You look at the nature of the diagram and you'll be able to choose a condition very well. Right. Here we are given a quadrilateral defined by the point C, W, X, Y, Z. So as I said earlier, that each time we're handling problems in geometry, it's good that you first begin by drawing a diagram as the first point of reference. It works better. So it'd be like W, X, Y, Z. I'll draw the diagram itself like this one. Look at this. W, X, Y, Z. Just a sketch. A sketch. Then they'll tell me that one W, X, Y, Z is a quadrilateral in which angle W, that's a W, sorry, that's a X, W, Y. Right, of course, it looks as if it is obtuse. Sorry, it's as an acute angle, but we can still more twist that one out so that we have really to show that that one is an acute. That's the way we do by sketch. Right, you can love that and have it like this one and go something like this, because the other angle there or of course just acute angles, but still more, let's have something that will look more like this one here. It's better, but it's just a sketch. Right, so here W talk of X, Y, Z, and we have angle XWY, XWY. So it means you go to that direction. So it means to go of x, w, y. So here you have a line that goes like this. So this angle here is given as 42 degrees. WXY. 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 80 degrees. So indicate there as 80 degrees. And the WZX. Look. WZX. Going this way, like this. That angle is this one. WZX. That is the what? 58 degrees. Right. So we are asked one to show that a quadrilateral is what? Cyclic. Secondly, when we conclude by just describing the points W, X, Y, Z are what? Concyclic. So it'd be like any one of the two questions. They may just ask you directly to this, show that W, X, Y, Z are concyclic points. Right. Or else they'll say, can you show that W, X, Y, Z is cyclic what? Quadrilateral. So from the page of the issues here, we're discussing here, I think to us, we can be able to trace the ideas of our discussion as to say, if I would need to show that points are concyclic, I think definitely, first of all, we need to prove that the quadrilateral that makes that points, okay, that the quadrilateral that is made from those points is cyclic. So more like when you prove that the quadrilateral is cyclic, then the points are concyclic. Right, so now, let's see what we have here. Look, you see by just the design, the question asks us to show that W, X, Y, Z is cyclic. So if you were to choose a condition among the three, you can just see by the design here that this one is more like what we discussed in the first condition. So we are going to use that property of say, talk of the line segment subtends equal angles. But now if you can look at here, we don't have equal angles somewhere. We have got line ZY is subtending this angle here, ZY is subtending that angle. Or else XY is subtending this angle here, XY is also subtending that angle. But in this case, you look at the values, they don't show that the angles are equal anywhere. So what do? You try at least to calculate some angle there. Could maybe somewhere you can have a pair of equal angles which are maybe subtended by a particular arc. Not necessarily an arc, in this case, you talk of what? A line segment is more like a chord. So here, what I might do as a student, you will be able to just have, first of all, look at the diagram as such and be very observant to say, which angle can I calculate? Maybe can give me a proper direction as to where I should go. Right. So like in myself here, if I'm a student, you can be able to look at it very well and try to consider triangle WXY. Considering triangle WXY, in which I would try to calculate the value of this angle here. Let me try to calculate the value of that angle. If what I want does not work, then I'll look at it further. Which angle then can I calculate? Maybe the issue about the angles subtended by the same line called what segment are equal. Right. If it fails, then it's not cyclic. The quadrilateral is not cyclic. So let me have that in triangle WXY. You'd bear with me that say angle 42 degrees in that triangle and angle 80, but this angle here, XYW, they give us 180 degrees. So let me find this one here. So here I am, angle XYW plus 80 degrees plus 42 degrees, that gives us 180 degrees. You know that? The property of which, just like angle sum over a triangle. Right. Now, if we take the sum over this is W, we talk of W here, sum over 80 and 42, that give us 122 degrees. Like that. So this one is equal to 180 degrees. Right. Now, having found a sum of 80 and 42, 122 degrees, we can arrange the items together. So this one, we go to the right hand side and be with 180 degrees. And this one we're going to observe. We'll have left hand side having the angle that's a XY W, which will be equal to then 180 minus 122 degrees. And when we subtract that, we're going to obtain an angle of 58 degrees. Right. So which means in this case, this angle is also what? 58 degrees. Right. Now, I come now to the conclusion. I found this one is 58 degrees. By calculations, you see what I've done is not just a matter of saying that one is equal to that. No, you do a calculation. So from here, I would see that here there's 58, here there's 58. The next question I have is that, are these two angles, maybe somewhere, are they subtended by the same line segment? So if I can follow up this angle here, which has been made by this line and that line, I would see that this angle is having a source from X and W. So it means WX is subtending this angle 58. And when I come here, this angle 58 is made by these two lines here coming from Z. And where having the sources, you feel that the same points W and X. So you'll be able to see that I'm also coming back to the same line. So it'll be like line WX is subtending this angle 58. Line WX is also subtending angle 58. Then by that, you be able to conclude that the quadrilateral is cyclic. Right. So you say here, say, therefore, since angle that is that is XYW is equal to angle WZX. ZX. This is equal to that. Right. Therefore, you conclude that say 1 WXYZ, the entire quadrilateral is cyclic. Talk of the WXYZ is cyclic, because that's the demand of the first question. Then once that one is cyclic, what do we expect the points? About the points. The points must again lie on the circumference of the circle. Right, and that is true. So therefore here you also conclude to say, therefore, you can also write maybe just an opening statement aside before you just cover that one out. You say, since WXYZ is cyclic, then you conclude to say, therefore, what? W, X, Y, and Z as points are what? Concyclic. Right. So by that, it means you have also shown that the points are concyclic. That's the demand of the second question. So this is the way we do. Right. So at this moment in time, we need to stop here. We're going to meet again in the other videos where we need also to look and discuss the type of questions that we would expect by the other two conditions. That's if the opposite angles of the quadrilateral are supplementary, and if the exterior angle of the quadrilateral is equal to the opposite interior angles. Right, so that we really be conversant of what we're doing, because some questions come very complicated, whereby you need to at least have knowledge about it. So when they ask you to prove a particular quadrilateral is cyclic, and again maybe talk of the points are concyclic, these are the stages which we take. Right, thank you very much for being together in the video. Right, I expect a lot of improvement in you. Revise what you learn at your school, and again follow the videos in the link as part and parcel of the revisions. Right, so my dear students, we'll meet again in the last discussions where we have 2 more lessons in order to cover up the entire topic. Right, then I'll give you an exercise to write. But before that, we need at least to finish the remaining 2 conditions. Thank you very much.